Question. A particle of mass m is acted upon by a force F is equal to F naught cos pi by 2 t. The distance traveled by the particle when it stopped first time. Initial velocity of particle can be taken as 0. So, first thing what is given to us, and next what we want to calculate it here. So, a particle of mass m is acted upon by a force F is equal to F naught cos pi by 2 into t. So, I will write F is equal to F naught cos of pi by 2 into t. Next, the distance traveled by the particle when it stops first time. We want distance travel. So, from force, we want to think a method where we can calculate distance travel. So, what I do? F by Newton's second law equal to m into a. So, m into a is equal to F naught cos of pi by 2 into t. So, acceleration first step I am going to get F naught by m into cos of pi by 2 into t. Now, I have acceleration with us. So, first step what I can do? I can write this as a function of time. Acceleration. First we can calculate velocity. A we can write it as dv by dt. We can get the velocity. Once we know velocity, velocity can be written as dx by dt. So, we can again get the value of x. So, first step what I do? I'll write here acceleration as dv by dt. Velocity as a function of time. So, dv will be equal to F naught by m into cos of pi by 2t dt. Integrate on either side. 0, initial velocity is given to us as 0. The final velocity at that particular point when it stops for the first time, that is v. That v also we can substitute as 0. Let me call that time as t naught. 0 to t naught, the time at which first it stops. So, immediately we can get the value of t naught. So, velocity v we can get, time t naught we can get. So, first thing what I do? Integrate 0 to v dv is equal to F naught by m 0 to t cos of pi by 2 into t dt. So, we get it. V is equal to F naught by m into pi by 2 sine of pi by 2 into t. This is the velocity we got it. Now, distance traveled by the particle when it stops first time. So, let us take when the particle stops first time. Stops first time means velocity is equal to 0 when t is equal to t naught. Substitute in this equation. 0 is equal to F naught by m into pi by 2 into sine of pi by 2 into t naught. So, we can get this value. When will be pi by 2 into t naught? Sine of this function should be equal to 0. What we are going to get from here? T naught is equal to 2 seconds. So, at this time, the particle will come to rest or the body will come to rest or stop for the first time. Now, since velocity we know, we can write it as dx by dt. Dx by dt is equal to F naught by m into pi by 2 sine of pi by 2t into dt. Now, let us integrate this 0 to x, time 0 to 2 seconds or t naught seconds. So, what are you going to get? X is equal to 2 F naught by m integration 0 to 2 seconds. Now, sine of pi by 2 into t into dt. Integrating, we get this one as 8 F naught, here pi is there, 8 F naught by m into pi square. 8 F naught by m pi square. 2 F naught by m pi square, this is wrong answer. 4 F naught by pi square m is wrong answer. 8 F naught by m pi square. Option C is the correct option. D 0. 0 is wrong option. So, is it clear what we have done here in the first time? First we calculated acceleration. Then acceleration we wrote dv by dt. We got the value of velocity. Now, what do we want? Velocity to become 0, time we need to calculate for the first time. So, we got the time as 2 seconds. Now, since velocity we can write dx by dt. Again taking dt this side. Again integrate it. This time from 0 to x and 0 to t naught. What is t naught? 2 seconds. So, 0 to 2 seconds we substituted here. 2 F naught by m pi 0 to 2 sine pi by 2 t dt. X is equal to 8 F naught by m pi square. So, correct option is option C.